Hello everyone, we are going to solve problem 98 of chapter 2. The force F has a magnitude of 80 pounds, so the unit system is pound here, and acts at the midpoint C. So the question is telling us this point C at midpoint between point A and B of the thin rod. Express the force as a Cartesian vector. So we have only one force, we're not going to add them together, or we don't want to find the coordinate angle. We just want to represent this vector, which is 80 pounds. It only has magnitude in Cartesian vector. So we have three components. So for that reason, I need to find the unit vector between point C and point O. So F, force F, I have the magnitude is 80. I need to multiply it by the unit vector to get it in Cartesian form. So which unit vector is going from C to O? Here I'm going to write the coordinate system for you to be easier. Point O, what's the coordinate of point O? It's at the origin, so it's 0, 0, and 0. What's the coordinate of P? The X coordinate is between A and B, so it's halfway there, so it's 1.5. The Y coordinate is in the negative direction, so -1, and the Z coordinate is 3. So the question is telling us we have midpoint C. So if point B has a Z component of 6, it's 6 feet, and point A is 0, halfway would be 3. Same thing for the other one. Now, before I find the unit vector, I need to find the position vector. So RCO, what is RCO? The coordinate of O minus the coordinate of A. So that means the 0 minus 1.5, I 0 minus -1. So let me write it directly here. That would be -1.5i plus 1j -3k. 0 minus 3 would be -3k. And the unit system is fit. UCO is just the position vector divided by its magnitude. So all of that divided by 1.5 plus 1 plus 9. If the result would be 3.5, to make it an integer number, I multiply the numerator and denominator by 2. So here I get -3. I multiply by 2. Here I get 7 plus 2 over 7j and -6 over 7k. It's a unit vector. It doesn't have any unit. Now I can multiply the unit vector with the magnitude. The magnitude was 80, and that's my unit vector. I multiply by UCO. At the end, I get -34.28i plus 22.85j and -68.57. So let's try to fit it here. And the unit for this one, again, we are dealing with foot-pound, is so we can see that we represented it in Cartesian form in 3 components. All we did was multiplying the magnitude by the unit vector. What is the unit vector? The position vector. So UCO is the coordinate of O minus the coordinate of C, going from position C to position O.